All right, welcome. Today, we're going to pull back the curtain on a piece of tech that you use all the time, probably without even realizing it has a name.
Okay, so think about this for a second. That two-factor authentication code that just hit your phone, or maybe a flight delay alert, a flash sale notification, they all just appear, right? Instantly. So how in the world do these companies send out millions, literally millions of these messages all at once, without a hitch?
Well, it's not magic, I can tell you that. What's really happening is this super fast, totally silent conversation behind the scenes, and it's all run by this one powerful, invisible protocol. It's basically the backbone for almost every automated text message on the planet.
And this unseen giant? It's called SMPP. So let's dive in and break down what it is and exactly how it works, step by step.
So, SMPP. It stands for Short Message Peer-to-Peer. And the best way to think about it is like a dedicated high-speed bridge. You've got your app on one side, it needs to send a text. And on the other side, you have the mobile carrier's huge SMS system, just waiting. SMPP, that's the super secure, super efficient bridge that connects the two.
Okay, to really get this, we first have to meet the two main characters in this whole digital conversation.
So on one side, you've got the ESME. Kind of a funny name, right? It stands for External Short Messaging Entity, but just think of it as the client. It's your bank's app, it's the airline system, it's whatever needs to send the message. And on the other side, that's the SMSC, the Short Message Service Center. This is the server. It's the big gateway owned by the mobile carrier that actually gets the message to your phone.
So how do these two, the ESME and the SMSC, actually talk to each other? Well, their whole interaction is this simple, really elegant 5-step journey that every single one of those automated texts goes on.
It all starts with a login. We can call that the bind. Then there's the handover, where the message is passed off. After that, you get the receipt to know it was delivered. There's a heartbeat to keep the line open, and finally, a nice clean goodbye. Let's walk through each one.
All right, step 1, the bind. This is basically the login. Just like you log into your email, the app, the ESME, has to prove who it is to the carrier's SMSC. It gives its username and password, basically, and it also has to declare what it wants to do. Is it just going to send messages, just receive them, or, do both? This whole process kicks off a secure, trusted session.
Okay, so once we're logged in, it's time for the handover. This is where the app uses a command called submit SM. Think of it like a digital envelope. Inside that envelope is everything that matters, who the message is from, the phone number it's going to, and of course the actual text itself.
So the SME is pretty much saying, hey SMSC, I'm logged in and trusted. Here's a message and where it needs to go. Take it from here.
And the SMSC fires right back with its own message, a submit SM RESP, which says, got it, I've accepted it. But here's the really crucial part. It also gives back a unique message ID. This is everything. It's like the tracking number from FedEx for your text message. It lets the app keep tabs on it.
And this is where that tracking number pays off. Step 3, the receipt. As soon as your phone gets the message, the SMSC sends another message, a deliver_SM, all the way back to the original app. This is the delivery report, or DLR. It's basically the SMSC saying, hey, remember that message with tracking ID XYZ789? Well, it's been delivered. Job done. But what happens if there's a quiet moment and no messages are being sent? You don't want the connection to just time out, right? That's where step 4, the heartbeat, comes in. Both sides will periodically send a little ping to each other. It's called an inquire link command. It's just a simple, you still there? And the other side replies, yep, still here. It keeps that connection alive and ready to go at a moment's notice.
And finally, step 5, the goodbye. When the app is all done sending its batch of messages, it doesn't just disappear. It sends an unbind command. It's really just a polite way of saying, hey, I'm all done for now, thanks. This lets both systems close the connection cleanly, no loose ends.
So let's just do a super quick recap of that journey. You bind to log in. You submit SM to send the message. You get a deliver SM as your receipt. You use inquire link as the heartbeat to stay connected. And you unbind to say goodbye. These commands, or PDUs if you want to get technical, are like the 5 most important words in the entire SMPP language. And that right there is the entire life of an automated text.
Okay, so you might be thinking, this protocol sounds kind of old school, right? It's been around since the 90s. With all the fancy new APIs and web stuff we have today, why on earth is SMMPP still the king of bulk SMS?
Well, the answer comes down to two words: speed and scale. SMTP was built from the ground up for one thing: insane throughput. We're talking about shoving thousands of messages per second down a single pipe. And for a business, that's not just a nice to have, it's absolutely critical. Think about it. A 1-second delay on your 2FA code, that could be a lost customer or someone locked out of their account. Speed is everything.
And it's not just about the speed. There are other huge perks. It's incredibly reliable, because those delivery reports give you proof that a message actually got there. It's flexible, which is why your emojis and other special characters show up perfectly. And it's super efficient. It can send and receive messages at the same time over the same connection. It's a real workhorse.
So from now on, the next time one of those instant codes or alerts pops up on your phone, you'll know exactly what's going on just beneath the surface.
Because you know it's not just a simple message appearing on your screen. It's the grand finale of that super fast 5-step conversation we just talked about. A whole back and forth between an app and a carrier, all happening in the blink of an eye, all speaking the secret language of SMPP. It's this hidden protocol that really makes so much of our modern digital life even possible.
And really, it just goes to show how many of these complex, totally invisible systems are working around the clock just to make our technology feel simple and seamless. It kind of makes you wonder, right? What other invisible protocols are out there quietly running the rest of our digital world?